In ancient Roman mythology, Jupiter overthrows his father, the immortal Saturn, to initially claim his throne and become king of the gods. In November of 2019, however, Saturn climbed back on top, at least in one respect, an element of modern planetary science. That's when the gas giant, best known for its stunning rings of rocks, ice, and dust, was bestowed a new title. Saturn is now the new Moon King. Okay, Saturn and Jupiter have traded this position back and forth for decades. But Scott Shepard, an astronomer at the Carnegie Institution for Science, believes that's all over. His work with the powerful Subaru telescope in Hawaii likely cements Saturn's crown by increasing its total moon count to 82. 3 more than Jupiter's 79.
And we thought we might find 1 or 2 new moons, but finding 20 new ones, plus a few more we're trying to follow up as well that are very faint and hard to track, was very surprising.
Surprising, in part because Saturn is about twice as far from Earth, and therefore more difficult to observe than its primary competitor, Jupiter.
It's easier to find moons around Jupiter because Jupiter is closer to the Earth, and so a smaller moon would be actually brighter because it's closer to the Earth.
But the tools available to Shepard today are much better than when he first began this research. Able to detect the movements of ever smaller objects against a relatively static star field.
My career in the last 20 years or so has been using the new technology of wide field digital detectors to just find kind of what's out there, what goes bump in the night. In the 1990s, it was like looking through a straw. It was a very small area of sky you could look at any one time. The cameras we use now are as big as a small car, very massive cameras that allow us to cover 10 full moons in one image. And by using this most modern technology, we're able to go fainter than anyone else has in the past and cover the whole area around Saturn, which is usually hard to do because Saturn is a fairly big planet, so there's a lot of area around the planet to search.
A big planet, it turns out, with lots of small satellites. Many of Shepard's discoveries are just a few miles in size, or just about 60 city blocks. Which begs the question, what exactly is a moon?
And a moon has a very simple definition. It's just simply an object that orbits a planet. But yeah, as we find more and more of these objects, we may have to start calling them dwarf moons or something.
But many might not always have been so small. Turns out, the Saturnian system was shaped by forces not unlike boardwalk arcade bumper cars, a smash and crash environment. 19 of the 20 new finds orbit Saturn in a trio of distinct clusters, suggesting shared origins for each group, at least 3 larger objects which didn't survive intact from the chaos of the early solar system.
And so it's likely that these moons were hit by comets and asteroids that are just flying past Saturn over the age of the solar system, and has broken these moons apart, and that's why we see basically a lot of fragments from these collisions.
And that 20th moon Shepard located, it orbits Saturn in the opposite direction as those on a similar orbital plane, hinting at a different kind of cosmic crash.
And so we think it might be a remnant of what we call a moon-moon collision. We think this moon, this object, is the remnant of a moon that collided with one of the other moons. And the other moon was probably bigger, and it has ground down this moon to dust.
In many ways, the development of the Saturnian system paints a picture of the solar system's evolution on a smaller scale. Clouds of dust and debris, rocky bodies violently smashing together and apart, giving birth to new celestial objects. Even here, much closer to home.
Well, the standard model for the origin of the moon is a giant impact, we call it the giant impact.
4.5 million years ago, a young Earth was hit by something like a sibling planet named Theia.
Theia was essentially another proto-Earth. There were a number of these objects flying around, and Theia took time to grow just like the Earth did. They probably had rather similar histories, and for one reason or another, the orbit of Theia was perturbed such that it collided with the Earth. It was such a massive collision that both bodies were melted in the collision.
Earth absorbed some of its astronomical assailant, but the devastating impact dislodged portions of our planet's mantle, which fused with particles in space. The remains of Theia, becoming the moon we see in our night sky today.
And eventually the moon formed out of the debris from that collision.
Unlike Saturn's remnant moons, Earth's moons survived its bombardment of asteroids and comets in one piece, providing the tidal force that influences our oceans. But its orbit expands almost 4 centimeters each year. What will that mean billions of years in the future? One recent study suggests the moon could escape Earth's orbit. Another, more widely accepted theory says it will settle into a stable, yet much more distant pattern, increasing a lunar month to 47 days. Laying out the chart of Saturn's system, Scott Shepard's new moons lie in the outer reaches of the planet's orbital configuration.
There's the famous rings, which are very close to Saturn, and then most of its larger moons, such as Titan and Enceladus. Those are about midway out of Saturn. And then very far away are these new moons that we're finding, very distant from Saturn.
In the most far-flung regions of Saturnian space, it's no wonder these small, barren bodies manage to remain hidden to human instruments. Even while the prolific Cassini space probe explored Saturn up close, relaying the most detailed examination of the system ever, including mountains of data and beautiful images, powerful portraits of the gas giant, its rings, and most intriguing moons, Titan and Enceladus. Cassini's Little Hitchhiker, the European Space Agency's Huygens probe, scored the most distant off-Earth landing when it touched down on Titan, a world surprisingly familiar.
And as those first pictures came back, we just saw more and more haze and fog and haze and haze, until finally the probe broke through that haze and we got to see the surface of Titan for the first time. We saw river channels on the surface. We saw evidence of dunes, and we could see rounded pebbles of water ice. So we knew a liquid had flowed on Titan. So amazing to see such an Earth-like world so far from the sun, where it's so cold.
The chemistry which is going on in Titan today resembles, in some way, the chemistry that occurred on Earth before life evolved. It tells us what kinds of naturally made molecules would be there in the stew out of which life eventually originated.
And beneath Titan's icy crust, a vast ocean of liquid water, perhaps containing life forms sustained by carbon-based compounds seeping down from the surface. Scientists continue to work with Cassini's valuable data. In late 2019, releasing a geological map of Titan and geochemical modeling of what lies beneath the frozen surface of the 314-mile-wide moon Enceladus. 4 years earlier, Cassini flew through the stunning geyser plumes, ice, and gases that continually erupt from the cracks in the ice at the moon's south pole.
To our surprise, we found out that in looking at the particles, the ocean was salty. And it was salty and had a very similar pH to our own ocean here on the Earth. We found all kinds of other organic molecules. We had ammonia and methane. We have carbon, hydrogen, oxygen, nitrogen. So we have the ingredients for life.
In 2017, Cassini's mission ended as it nosedived into Saturn's atmosphere. a deliberate course of action taken by its controllers to protect the integrity of Saturn's potentially life-harboring moons.
Cassini has changed the paradigm of where we might look for life. You could be a world around a giant planet and have conditions that are right for life.
Perhaps another jewel in the Moon King's crown. For now, though, Saturn's new nickname simply refers to the number of moons circling the planet, not any biological attributes. Scott Shepard continues his work with the Subaru telescope, observing the environment around Saturn and beyond, just as he did the first time. Physically earthbound, but atop Hawaii's 14,000-foot peak Mauna Kea, exploring space in mind and spirit.
It's like being on a whole nother world. And it was one of the greatest experiences, staying up all night, just observing and looking at stars.